Nuclear power plants generate decades of safety data, spread across disconnected systems, difficult to access, and underused when it matters most. With Curiosity, that knowledge can be connected across inspection letters, incident records, and regulatory decisions, and made available to the people who need it in seconds. Here's what that looks like in practice. Behind every search and every analysis is a knowledge graph, a structured map of the data and the relationships between documents, systems, sites, and events going back decades. That connected structure helps experts navigate the full depth of the historical record and gives the AI the context it needs to produce analysis that is traceable, not just plausible. Here are 3 scenarios showing how inspectors use this in practice. In the first scenario, an inspector is preparing for an upcoming visit. They have a specific system and site in scope, and want to know everything the historical record can tell them before they arrive. They search by theme or system, apply filters to narrow down by site and period, and select the most relevant inspection letters from the results. With a short list of letters selected, they launch the synthesis. In minutes, Curiosity produces a structured report covering key figures, recurring issues, associated demands, and a prioritized list of points to focus on during the visit. Every claim links directly to the source letter it came from. The inspector can refine or export the full synthesis, a sourced briefing document ready before they've set foot on site. In the second scenario, that same inspector is back from the site with raw notes. They paste their observations directly into the interface and run the analysis. Curiosity extracts the key entities from the notes automatically, then cross-references them against the full historical record. The most similar past case surfaces at the top, scored by both semantic and relational matching, with a direct link to the source document. Below that, similar cases from the same site and from across the wider 900-megawatt fleet are ranked and listed. Scrolling down, the inspector sees a structured synthesis, qualified findings, proposed corrective actions, and points to verify before writing up. Everything is traceable back to the graph. When they're ready, the full synthesis is one click away. In the third scenario, a safety incident has been declared on a specific reactor. The inspector needs to understand what happened and whether the warning signs were already present in the historical data. They filter by system and site and select the incident that comes up. The incident record shows a summary of the event, its site, and its INES classification. Below that, Curiosity has already identified similar incidents, each scored and ranked by relevance. Clicking into any of them opens a detail view with a link to the original source on the ASNR website. The inspector triggers the weak signal analysis, and the results populate as a structured report covering similar incidents, precursor findings, and a fleet-wide safety view. Every result links back to its source. The full analysis exports to Word in one click. What used to require days of manual search through thousands of documents is now structured, sourced, and ready to act on in under a minute. This is one example of what Curiosity and Capgemini can build together, connecting the knowledge that already exists and making it available at the moment it's needed. Curiosity and Capgemini, industrial AI made real.